Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. There can be many ways to approach a problem, but when it comes to competitive exams like JEE or NEET, you should choose the shortest and the smartest possible path. Let me give some examples. Look at this question. A particle is projected vertically upwards with a speed 60.23564 meter per second. Find the speed of the particle 1 second before it reaches maximum height. So when a particle is projected with certain speed u upwards, obviously the acceleration is downwards, the speed is certainly decreasing, it goes to certain maximum height and it falls down. The question is to find the speed of the particle 1 second before it reaches maximum height. So this is the maximum height, and 1 second before it reaches, it is somewhere here. So at this point, what is the speed? Now to solve these, if you start applying equations of motion and solving for the speed, so first finding the time taken to reach maximum height, then do t minus 1 and find the speed at this point, then you are lost in the loop. This can be solved in less than 30 seconds. Look at this approach. At the maximum height, the speed of the particle is 0 and acceleration is g meter per second square, which is approximately 10 meter per second square. It means that the velocity is decreasing at the rate of 10 meter per second in 1 second. 10 meter per second square is 10 meter per second per second. So the velocity decreases at the rate of 10 units in 1 second. So at the maximum height, the speed of the particle is 0. So 1 second before reaching the maximum height, how much should be the velocity so that it decreases by 10 and becomes 0? Obviously, it should be 10 meter per second. Only when it is 10 meter per second, then 10 is subtracted from this and it becomes 0. As simple as this. If the question is, what is the speed of the particle 2 seconds before reaching the maximum height? The answer would be 20 meter per second. So 2 seconds before reaching maximum height, it is 20. So next second it becomes 10, next second it becomes 0. That is where it reaches maximum height. So less than 30 seconds, you can solve this question. Answer is 10 meter per second. Not just this, if the question is, what is the speed of the particle 1 second after reaching maximum height? Same thing. Now at the maximum height, the speed of the particle is 0, then it starts gaining velocity at the rate of 10 meter per second square. So next second, the speed would be 10 meter per second. And the direction of velocity would be downwards. That's the only difference. Let us take another example. A particle is projected upwards. It crosses a point at t is equal to 2 seconds and t is equal to 10 seconds. Find the time of flight of the particle. Say a particle is projected vertically from certain point on the ground, it goes to maximum height and comes down. If you observe the motion of this particle, every displacement or every height or every point is crossed twice except the maximum height. Maximum height is happening only once, but the particle crosses every point twice while ascending and while descending. So that is the reason it crosses a point at t is equal to 2 seconds and also t is equal to 10 seconds. So t is equal to 2 seconds, let me say this is a point. So t is equal to, the time here is t is equal to 2 seconds. So from initial point to this, so this is the time elapsed from initial point of projection to this point. And now t is equal to 10 seconds. So t is equal to 10 seconds is from the point of projection to maximum height, again reaching this point while the particles descend, while during the descent, again it is at the same point. So this is the time which is t is equal to 10 seconds. Even if for this question, if you are applying some equations and trying to solve, it is just waste of time. There is a smart way to approach this problem. The question asked is to find the time of flight of the particle. Now look at this. Time of flight of the particle is nothing but time taken by the particle to come back to ground again, come back to the point of projection. So if you observe the green line till here, it is 10 seconds. Now all you need is the time from that point to the ground, the white, the time elapsed for the white displacement. Don't you think that is again 2 seconds? If the time taken from the ground to reach the particular point is 2 seconds, while descent also, from that point to ground, the time taken will be 2 seconds because it is the constant acceleration. of the particle, it is always g downwards. So this is also equal to 2 seconds. Now time of flight is just green plus white, which is equal to 10 seconds plus 2 seconds. The answer is 10 plus 2, that is 12 seconds. As simple as this. This is method 1, pure logical way of approaching this problem. There is method 2. To approach the same problem, for this particular case, the equation of motion would be y is equal to ut minus half gt square. Let me say the certain point which it is crossing is at a height h. So the displacement h happens at 2 instants of time. So substitute y as h in this. I am trying to find at what time the displacement h happens. And I've got a quadratic here if you observe. So you don't bother about the u is not given and we don't have to bother about this. H is also not given, we don't have to bother about this. But look at this equation, it's a quadratic which says that height h happens twice. There are 2 values of time where the displacement of the particle is equal to h. Solve this quadratic, it's gt square minus 2ut and then plus h, 2h is equal to 0. This is a quadratic equation in terms of time t. There are 2 values of time, one is t1 and t2. So what is given to us is t1 and t2. Now the sum of roots of a quadratic equation t1 plus t2 is minus b by a. So b is minus 2u minus b is minus of minus 2u, that is 2u by g. Don't you think 2u by g is the time of flight of the vertically projected body? So the answer to this question is simply t1 plus t2. So the 2 instants of time, if you add them up, that is 2 seconds plus 10 seconds, the time of flight is 12 seconds. And not only that, not only the time of flight, we can also find the speed of the particle, initial speed with which the particle is projected. How? From time of flight. Now I know that time of flight is 12 seconds, that is equal to 2u by g, that is 10. So 2 ones and 6. So u is equal to 60 meter per second. This is the initial velocity of projection. Not just initial velocity, you can also find the height h, where it is crossing the certain point. The height of that certain point, the particle is crossing at t is equal to 2 seconds and t is equal to 10 seconds. That can also be easily found by applying product of the roots t1, t2, that is c by a of the quadratic. C is 2h by g. So t1, t2, that is 2 into 10. 2 into 10, that is equal to 2h by 10. 2 is gone. H is equal to 100 meter. This is the solution to this question. Very simple way, less than 30 seconds you can solve this question by adding up 2 and 10. The answer is 12 seconds. Let us see one last example where there is a smart way to approach a problem. Find the average velocity of the projectile u comma theta. Between the instants, it is at half the maximum height. So draw the figure. This is projectile, initial velocity u, angle of projection is theta, the maximum height is this. The question is, this is the maximum height h. It is at half the maximum height at 2 instants of time, obviously, while ascending and while descending. Between these 2 instants, say A, this is happening at A, this is happening at instant B. So A and B are the names that I gave to the instants, the moments. So while ascending, it crosses the point where the height is half the maximum height. Again, during descent, it crosses another point where the height is half the maximum height. And between these 2 instants, you are supposed to find the average velocity of the projectile. If you try to solve this by getting equations, it becomes complicated. There is a very, very simple way of looking at this problem. We know that the horizontal velocity of the projectile remains constant, which is u cos theta, and this remains u cos theta throughout. What changes is only the vertical component. So along the horizontal direction, the average velocity is always u cos theta because it is uniform. But there is only the average velocity which is varying in the vertical direction because it is non-uniform. Now between these 2 points A and B, the average velocity, the definition of average velocity is total displacement by total time. Now the displacement is only horizontal. There is no vertical displacement because it is coming to the same level. Vertical displacement is 0. Vertical component of average velocity is 0. There is only horizontal displacement, horizontal component, and the horizontal component of projectile velocity is always u cos theta. So the answer to this question is simply u cos theta. Done. The average velocity between the instants where it is at half the maximum height is simply u cos theta. It's over. There is another method, method 2. We can use a little bit of math. Let me say it is reaching point A at time t1 and point B at time t2 from the initial point of projection. Now the displacement covered from point of the horizontal displacement covered to reach point A, that is u cos theta into t1, and the horizontal distance covered to reach point B, that is u cos theta into t2, and the displacement between these 2 points is simply u cos theta into t2 minus u cos theta into t1. This is the total displacement by total time, that is t2 minus t1, which is the average velocity in the horizontal direction, and I am left out with simply u cos theta. 2 steps, but just knowing the fact that there is only horizontal displacement, there is only horizontal component, and it does not change, we can directly say the answer to this question is u cos theta. So there are many such techniques and smartest ways to approach a problem. I'll try to cover that in the future videos. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.